Good morning, guys. So we are going to look at your biological statistics pack. We're going to start on the second page with an idea called discrete and continuous data. So it says on the top here that the quantitative data can either be discrete or continuous. So after reading through everything, discrete data is something like if we toss a die 50 times, we're going to get a big string of 50 numbers and we can get a frequency of every single number. Discrete data is very, very specific and it doesn't put things into categories. Whereas continuous data can basically be anything. The example that they use down here is if we have 200 men, their average height is 64.328 inches. We're not going to find a guy that's exactly 64.328 inches. They could be anywhere in that data range. So that's continuous data, where they can take any number within that range, or we put them into categories. Like you could be 58.5 inches tall to 60.5 inches tall. So I like to think of it as discrete data is very, very specific when every single individual is listed, and continuous data is kind of how we lump stuff together to make it a little bit easier to look at. So when you go down to looking at trichomes, so trichomes are a part of a plant where you can actually look at how many trichomes are on a fast plant, which is a special type of plant whose generation time is very, very close together that we use for genetic studies and breeding and different things like that. So with this, we actually have an Excel spreadsheet of the data that's listed here. So this one up on top, we have every single individual listed. That would be our discrete data set. If we look down here, now we're seeing every single individual is listed, but now we put them into categories. So this would be a continuous data set. So for example, in this third bar on the histogram, 6 to 10. So everyone in there could be 8. Everyone in there could be 7, or we could have 2 6s, a 10, all of those different things all mixed together. So that would be a continuous data set. So when we keep going down, it walks you through mean, median, and mode, just remembering all of that stuff. And then down here, it's showing you how to do some things in Excel. So it says, open the Excel spreadsheet Trichome Data XLX. This spreadsheet is linked in Schoology, and then it says it contains the raw data from the experiment above. Okay, so what we are going to do is calculate the mean, median, and mode. So what I am going to do, we're going to label the columns I, J, and K with mean, median, and mode. So I'm going to go in there. This is the document open, mean, next one, median, next one, mode. So flick back to our next instructions, and then we're going to calculate our mean, median, and mode. So to do the type of data, you're going to make an equal sign in the appropriate cell that brings up a formula bar. Select average for mean, then median or mode, and then select all the data and hit enter. So the way that we do this is you're going to click on mean, type equals, and start typing in average. So we're going to click on where it says average. So we're going to type that all out. So here we have our plant number and our trichome number. So I'm going to highlight all of my trichome numbers all the way down. And then I'm going to close my parentheses and click off, and it calculates it for you. So in the next one, equals median, same thing. Highlight everything, close our parentheses, click off, that's our median. Lastly, equals mode, highlight everything, close our parentheses and click off 13. So we have the most 13 trichomes. So the next one says that we are going to sort. So it says put everything from column A into column B. We're going to use B to C. So we have our trichome numbers. We're going to label this one sorted data. Sorted data. I'm going to copy every trichome number, Control copy, put it into my sorted data, Control V is paste, and then from here up in the corner, we're going to go to sort and filter. So sort from smallest to largest, and we're going to make sure we're clicking on continue with the current selection and sort. So now we have from smallest to largest sorted. Next, we're going to do frequency and bins. So let me just see where I have everything. We're going to do bins in the E column and frequency in the F column. So if we go here, we are going to label this bins and then F frequency. All right, so if I want to measure every 10, so in my whole set, I want every 10 measured, I'm going to type in the high number. So I'm going to measure everything that's 0 to 10, and then the next one would be everything that's 11 to 20. The next one would be everything 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, and so on, however many bins that you think you need for your data. So then we're going to do frequency. And instead of counting everything up, we're going to make us do it for it. So now to find our frequency, we're going to click on equals frequency. And then we need our array and we need our bins. So our array data is all of our trichome data, comma, our bins. And then it sorts it all for you. So we have 40 samples that are between 0 and 10, 37 samples that are between 11 and 20. Same thing for that. So if I made my bins every 5, just for example, so if I would do 5, 10, 15, 20, 25, 30, 35, 40, I could do the exact same thing. So I could click on equals frequency. I need my array data once again. Now highlight that whole section, comma, go up and highlight my bins. And there we go. So now it has sorted it even more. So you could keep doing this to get more and more and more bins when you are doing your data. All right, so the last one that's not on there is standard deviation. So I'm going to do another title that is standard deviation equals std or stdev.p. Okay, so that says that it calculates the standard deviation based on the entire population. So we are going to open that, highlight all of our trichome data once again. Instead of you guys doing all the math on that, close our parentheses, click off, and it tells us that our standard deviation is 8.8. So we already have our mean, which is 13.95. So I know that 68% of my samples are 13.95 plus 8.8 or less than 8.8. Most of my samples would be within that range. So that's kind of how to do some stuff on Excel. So I want you guys to play around with this. There are other really, really good, helpful things to use online, but be sure to ask for help as well if you need it.